Sorry for the delay. Okay. So the point was to discuss PCI device pass-through and several questions. Is there anything you want to discuss on the goals, or is there anything that is not clear for anybody?
When you say it's available on x86, it's not available for PVH, right?
Okay. Yeah, it's the concept is available with the VPCI. The VPCI is available on x86, but it's not available for all types of guests. Honestly, I could not confirm. For PV guests, it's available, but not for PVH. Could someone confirm or?
VPCI is only available for PVH DOM0 because it's not security. Well, it's not made to be available to unprivileged guests.
So it's only available for PVH actually.
PVH DOM0.
Yeah. What?
So fixing this for general PV guests is something on the for general PVH guests is something on the plan, but we don't have. It's not ready yet.
Yeah. The other thing is I'm not sure. How much would you share of that? Because I'm not sure the plan on ARM, but one of the proposals by Paul was to make his little tiny PCI pass-through emulator part of the Xen tree, basically, what's called Xen PT, which is something that runs in user space. So that probably wouldn't be suitable for DOM0 less or DOM-B or anything like that, I think. I'm not sure. But you will need to keep a domain running where the emulator will run in user space.
Right, that would work on B. You could just put it in the hardware domain.
Okay.
So you would put it in DOM0?
No.
Yeah, the hardware domain.
Hardware domain.
So in reality, there tends to be a lot of confusion over HVM and PVH domains. Part of that is down to their history, but ultimately, the only difference as far as Xen is concerned is whether there is a QEMU default IRX server or not. It is perfectly easy to take what is currently a PVH domain and add a custom emulator for a tiny thing. So a VTPM emulator for something, or a tiny emulator that only does PCI config space for one pass-through SRIOV function or something like that. Yep. So the infrastructure isn't fully wired up and trivially usable, but it is certainly possible. What we were wanting to do longer term with things like PVH was get to the point where things like SRIOV didn't require an extra emulator.
Well, the VPCI is fully relying on Xen emulation, so the PCI bus is emulated inside Xen, not inside the guest. In the current design, the I/O emulation for the PCI bus is done in Xen. We are not relying on a domain to do that.
Yeah, currently BPCI is inside of Xen because it needs to be used by DOM0, so there's no way you can put that in the user space of another domain. So yeah, that it's currently done inside of Xen. The question is whether you want to, whether we want to expand that in order to support unprivileged guests, or whether we would like to go another route.
What we did so far is the VPCI I/O handler, we activate it for guests. So the emulation is done inside Xen also for guests. If the guest is trying to access one of the I/O address of the PCI bus, then the exception is taken inside Xen, and we emulate the access inside Xen, whether it's DOM0 or a guest.
So in reality, that's what happens on x86 as well. At the moment, an HVM guest on x86 takes an I/O trap to Xen for MMIO, which gets emulated and then forwarded to QEMU. QEMU has its own emulation model as to what happens, and some of those get filtered out, some of them don't. Then QEMU using libPCI or a Sisyphus node gets DOM0 to make a change to the PCI device, which then gets trapped and emulated with a different set of rules by Xen before things go out. PCI pass-through on x86 is a chronic mess, and it needs to get more simple.
Okay, so from our current status, the implementation is a lot simpler because we don't go through this QEMU pass. Basically, we do everything inside Xen. Might also be coming from the fact that we are emulating on Xen PCI bus, for which the protocol is a little bit simpler. Well, we have an I/O space for the PCI configuration space, which might not fit for x86 actually.
There's no ECAM support in PV in HVM guests at the moment. It's one of the many things that we need to get sorted. Conceptually, it's quite easy. We've already got the emulation layer in it because we need to intercept DOM0's access to it. It's just that it is one of the many things that no one has got around to fixing yet.
You also can't give full access to the configuration space to the guest. You will have to sanitize it.
Yep, we do.
Yeah, you're always going to have to sanitize it, and the problem is at the moment in x86 models you've got 3 separate places doing sanitization under different rules. First is the emulation pass in Xen before it goes to QEMU. Then there's a sanitization pass in QEMU, and then there's a different sanitization pass because you're making it from a PV domain, not an HVM domain, when DOM0 comes to try and talk to the real piece of hardware.
Okay. Okay, so it's the status is fairly more simple on our side because DOM0 has direct access to the PCI bus, so we just pass through to the real hardware the requests inside Xen. But when you are a guest, we catch them and we give an answer depending on what was targeted inside the PCI bus. That's what you see that the guest is seeing this. Basically, we let him see this device, the bridges, so that he has a bus which is coherent, and then the bar values are actually not the hardware ones. But we don't have so much complexity right now, but maybe it's because we are not that far in the implementation. Am I missing something where you need so much emulation traps?
It's slightly more complicated on x86 because we also need to trap accesses to the MSI and the MSIX capabilities, for example, which I don't think you do on ARM.
No, not okay. We will. It's not done right now. On our status, we will start on MSI next quarter.
It's really going to depend what kind of MSI controller you want to use. If you're looking at CITS, then you won't have to trap the MSI because everything is protected by the hardware. You just specify a device ID. This is going to be fine. But if you look at the gigabit WEM where there's no protections, and yes, you will have to trap the MSI message and look at it.
So on x86, you need to trap them anyway because the MSI address and data field encode CPU and ERC number. So even on x86, when you're doing it transparently behind the back of the domain, you've still got to have that match up with what you program into the IOMMU. So there is no circumstance ever on x86 where you can avoid trapping and replacing the MSI address and data fields.
Okay. On ITS.
And regarding the bars, do you allow the guest to change the bar mappings? Do you allow the guest to change the physical address of the bars or the address where it's mapped into the P2M?
For now, no. But we might change this. So how this has been done. So on ARM, you have a static mapping which is defined for the guest. And we added an area where the IOM space of the VPCI bus of the guest is. We might allow the guest to change the value. We would not change the value in hardware. We would just change the MMU, the level 2 MMU mapping, so that we reflect what he requested.
But that's what we do on x86 as well, except that at the moment it's driven by QEMU and it's actually quite slow.
That would not be slow because it's directly mapping, so it the guest has direct access to it. We just need to make sure that the level 2 MMU mapping is reflecting what was requested by the guest. But for now, it's completely turned off. We just emulate where we want it to be.
Yeah, I mean, quite
You
a
have
lot
to
of
be
the
careful with
complexity.
that.
Yeah, quite a lot of the complexity on x86 also comes from this, because we allow DOM0 to change the position of the bars, both physically and inside of the P2M.
Well, allegedly. I'm not completely convinced it actually works if DOM0 goes and relays out the PCI bus.
No, I mean, not at all, but we allow it to change. I mean, it can size the bars and it can change, it can write to the bars and change the position, and then this will reflect into the P2M. Whatever that's something that you really want to do, it's another thing, but also part of the complexity is because of that operation. It's a non-trivial operation, it's a long-running operation, and we need to defer somehow to the idle vCPU or something like that, because you cannot do the full mapping inside of a trap, because it takes far too long and you will trigger the watchdog.
Yeah, so for example, on x86, we've got, particularly when we're doing graphics virtualization, you're getting cards with 8, 16, 32 gig bars these days, and a reoccurring problem with x86 is that no one has implemented superpage support for the IOMMU. So currently that's doing 4K mappings for that. They're genuinely, at the moment, Xen server with a NVIDIA T4 card wastes nearly 3 minutes on boot making the IOMMU mappings for the bar.
Julia, you said that we must be careful with mapping, and you stopped. What was your remark on this?
Because some of the PCI address are actually bypassing the IOMMU. It's not on all the hardware, but you will have to be careful with that also. Some
addresses are
at least the doorbell on some of the hardware, I think it's on Huawei, where it's going to bypass the IOMMU. So even if you put your PCI device behind an IOMMU, it's not going to go through it for some of the translation.
So this is where we actually got to, so the section on setup, enumeration, and configuration. So there was a point there that I wanted to raise here.
Just to follow up on that, we already got an issue because we got stuck on our implementation, because actually currently ARM guest memory is programmed to be at 0x4, and PCI buses, some of them or lots of them, are forbidding access under 0x8. So we had to move the guest memory for now so that we could bypass this issue. DMA access were simply forbidden because the hardware memory is at 0x8. So the PCI bus is not, the PCI bus DMA access are simply refused by the PCI bus before they can even reach the IOMMU. This was kind of of a surprise.
So
you have to investigate this one.
How does Linux deal it? Because Linux doesn't use...
Because his memory is at 0x8. The hardware memory is at 0x8, so he will never try to do a DMA access with 0x4.
But if you do an IOMMU in Linux, they don't use the same address as... They don't use a CPU physical address, they use a device physical address, which is different one.
Possibly they don't use 0x addresses under 0x8.
Okay.
Raoul, did you check on that? Or are you in the call?
Yes. So what is the problem is like that guest Linux is configuring the DMA address below 2 GB. And our physical RAM is around 0x8. So that is the problem, yeah.
But Linux is never programming a DMA address under 2 GB. Is that always, or that only on the Juno board, or something like
that? We found on Juno board, yeah. So for that case, we have, because the Linux driver set the DMA, it depends on DMA set bit mask that you set during the drivers. So we have set it that about 2 GB, but that is not going to that one. It is always setting below 2 GB on Juno board.
The question was, is that something any of you know to be existing on any other hardware, or is it specific to our board right now? We are only testing on one hardware, so we are kind of limited on that area.
What you will very quickly find is that every piece of hardware is broken. It behaves in different ways. No two pieces of hardware will be the same, and I have yet to find an x86 system that actually works correctly. Even modern laptops are quite bad. Everything that's integrated into the SoC is not actually electrically isolated, even when you think you've programmed the IOMMU contexts correctly.
Okay.
There's a huge long list of errata to do with access control services and things that claim they're enabled and they're not actually enabled, backdoor ways of checking whether it's enabled safely or not. This is why the list of quirks is so large.
Yeah, that means we will, surely we will end up with a need to have PCI quirks implemented inside Xen if we want to support more and more
we already have a few of them in x86. Certainly in the past, it was expected that Xen not be involved in this, but frankly, that was a mistake a decade ago. That came about because it used to be the case that Xen came up, did RAM and virtual CPUs only, and DOM0 did everything in hardware. But as soon as you start getting the concept of I/O isolation, that model of booting broke down. So now Xen needs to enumerate the PCI bus so it can figure out how to program the IOMMU correctly. And that in turn means that we're a decade behind in actually having a competent PCI subsystem in Xen. So again, these are areas we're slowly working on, but not necessarily going as fast as we would like.
Well, that's the plan that we have is starting this month. We will take the code that is running on Juno board and we will port it to an N1 SDP board, so another piece of hardware. And this one has a messed up PCI, so we will have the opportunity to see what kind of quirks we have to implement and how we can actually implement them inside Xen. But right now it's also part of the question on the enumeration, because I know that a lot of quirks are related to enumeration. And if we introduce enumeration inside Xen, we might fall into that trap.
So there is already code in Xen to enumerate it. It's in drivers pass-through, I think. I can't remember how much of it falls into x86 code.
It's pass-through IO.c or pass-through PCI.c or something like that, I think.
It's entirely possible it's not compiled for ARM at the moment, but we do have some enumeration code, and on x86 we know for absolute certain we're going to have to make that better, make it more robust, actually get it safe with, because the thing is, as you identified, we cannot rely on DOM0 being able to tell us the safety of how to program the IOMMU and set quirks on the bridge devices and all of that when we're trying to use the IOMMU to isolate a not totally fully privileged DOM0. And your options there are to trust hardware did it right or do it right yourself.
Not hardware, any previous firmware. So someone behind Xen doing it, or the user defining it. So it's putting inside the device tree something which looks like the PCI bus, which Xen could take and just say, I know I have to enumerate the bus this way, so programming all bar registers. This is not a perfect solution, but this is a solution which could fit some of the use cases where you don't want to have a DOM0. Because when you don't want to have a DOM0, most of the time you know your system already. So you could start Linux, check the enumeration, generate the PCI enumeration description, put it in your DTB, restart, and Xen would apply it. I kind of think well, we could try to enumerate the bus, but we will for sure go down into hooks, traps, etc. because this specific hardware has this specific borked controller or well, a messy graphic card that you want to put on a specific place or whatsoever. And,
also, there's an added
by
problem on
enumerating the bus,
x86.
doesn't really mean that you need
that's
to...
not a problem specific to ARM.
Yep.
But so one thing is changing the bars, and one thing is just enumerating the bus, like working down the bus and discover what's there and what's not there. So I mean, changing the bars, I'm ready to believe. I'm sure. I mean, there's all sorts of problems with that, right? And I'm sure Andy and Roger can testify to that. But just working down the tree, that should be like quote safe end quote, right? Just doing discovery. Right?
Definitely, that's
it's
what
a
I said.
mess
So
on ARM. Even discovery is a mess because if you expect to interact with DOM0 may discover the device in a different way that Xen is doing. So that was one of the problems we had when trying to play with discovery back in 2016 or something like that.
I think that's because on ARM the segments are not fixed or something like that, and you make the segments up as you go or something along those lines. I think we speak about that in the past.
In the device tree, you only say there is this PCI bus on that set. There is no, that's Linux and that will enumerate based on how we interpret the device tree.
Could you modify the device tree to pass that to Linux?
It doesn't help because there is no way to tell what's the segment number.
You have to make those up.
Yes, but you then end up to the problem where we are going to do something that is then specific and it may not work with other Linux, or you have to modify Linux.
Oh, so there's no way to pass the segment right now. I mean,
as far as I remember, there was no way, but that was 2 years ago, so it may have changed since then.
I have seen some stuff, but it was, I think, specific to NXP to implement some PCI fixes inside the DTB, but that was fully they never pushed this to the standard Linux kernel. But there are two parts. Either you have a DOM0. If you have a DOM0, you can rely on it to actually do the enumeration. So you don't need to do it inside Xen, because DOM0 can still declare you the devices.
You need to configure the devices.
Go ahead.
No, sorry, Andy. Go ahead.
You can't rely on DOM0 to do the enumeration there because you need to know the enumeration before you can construct DOM0. And that's fundamentally the problem x86 is in at the moment.
We don't.
You need to know the PCI controller because DOM0 will need to map it.
Yeah,
I think you know the PCI controller, but not where the devices are. You can rely on DOM0 to provide you back the devices, as we are doing right now.
The thing is that you need to tell...
Okay. Okay, Roger, I would say sorry. I will have to redirect. Go on. Roger?
The thing is that you need to tell DOM0 if your DOM0 is going to tell you the number of segments. DOM0 will not be able to tell you the number of segments that you need to know in Xen, but DOM0 may enumerate the segment differently. So you need a way between Xen and DOM0 to know this segment is the one I'm talking. It's quite a mess.
Okay.
I mean, there's an hypercall on x86 that PV DOM0 uses to notify Xen about devices, PCI devices, and it tells the bus, the segment, the bus, the device, and the function to Xen.
That's
the
what we use.
problem with that approach is that then when you issue, I mean, DOM0 won't be able to access the device until it issues the hypercall, because the hypercall needs to be the one that maps it into DOM0 P2M.
Which is what we do right now.
Okay.
So you have the Linux discovering the devices, declaring them to Xen, and we assign them to DOM0.
Yeah, but that logic isn't terribly safe. It's fine. It's fine when you have a single monolithic DOM0 that has been fully modified, but there are plenty of use cases where that is not an okay thing anymore.
Yeah, but in this case, you don't allow anybody else than yourself to actually enumerate the PCI bus. On a DOM0-less system, nobody would have access to the physical PCI. So if you do the enumeration in Xen and you just pass a vPCI bus to all guests on top of Xen, then you don't rely on those problematics because you declare yourself what you want to Linux. And you intercept any access to the PCI bus. So any changes tried to be done by a guest would be catched by Xen, actually. Or do I miss a use case in the middle that I...
So I think at the moment for PVH DOM0, it gets to see all the buses, but has any reconfiguration squashed. For general domains that have an individual thing configured through, it ends up appearing as a single device under the main QEMU bus. So the entire topology is virtual from the guest's point of view. It doesn't represent the system, and that's a consequence of how it came to be.
So, Julian, from what you recall of the problems of enumerating the bus from Xen, so what if we treated DOM0 like a DOMU, meaning that the bus exposed to DOM0 would be fake, no pretense of being the physical one, and the real enumeration of the physical hardware is only done by Xen. And then Xen will expose most devices, or let's say as many as it sees fit to DOM0, but it will do it with the same path. It will do it through DOMUs.
So it works in theory. In practice, it won't work because someone is typing on the...
Andrew, I think.
Oh, no,
sorry, being a little bit loud.
So it works in theory. In practice, it doesn't work because even if all the PCI may be ECAM, there is still some initialization that needs to be done for the PCI device. And even, let's take the example of Xilinx, but there is clock to enable. There is a lot of things to be done that people have been relying on Linux to do it rather than the U-boats. So I like the idea that everything can be done in Xen, but in practice, you will see that it's not going to be possible, at least in short term.
Okay. Yeah, I see what you're saying.
Clocks that you need to init don't require interacting with the PCI root, I guess, or something like that?
Yes, so some of them, so there are different things that not everyone is supporting ECAM or properly ECAM. So even if one said, I'm ECAM compatible, there will always be some quirk on the sides. And then a lot of Linux developers sadly took the liberty to initialize clock and things like that in Linux, when this should have been initialized by U-boats. So in some of the cases, you end up to pull thousands of lines of coding then just for enabling an ECAM PCI device. Juno is a nice board because pretty much everything has been done by the rule, but as soon as you looked at other boards, there is some quirks on Juno, but as soon as you look at other boards, it's a mess. It's a real mess.
And you need to do all this before even you can enumerate the bus. Without doing any of these, you cannot enumerate at all, I guess.
Yes.
Well, if we say that on the two solutions, you have your firmware must do that thing properly, or you do that in a DOM0, yeah, supposedly we could go without a quirk in Xen. Someone might want to implement it, but it should not find its way in the standard Xen code. It should be limited to, I don't know, board support specific implementation or something like that. Yeah. I don't think we should prevent it completely because someone might want it for its board and that's it.
I'm a bit concerned that we just end up to re-implement Linux.
So I mean, in practice, nobody. I mean, speaking as a vendor-specific BSP maintainer, like who is gonna write the support for clock framework in Xen? That would be like this. I mean, it's suicide, right? I mean, I wouldn't, and I certainly wouldn't try to upstream it. It's just too hard. Like if it was just a few writes here and there, maybe, right, you can find a way to do it. But the clock framework is not something, I mean, anybody sane will try to add to Xen. So
the clock discussion, I did not add that in my presentation because that's a huge subject and I don't want to introduce it now. But currently, what we think, there are two solutions. Either you have a simple clock system which is relying on, I don't know, firmware or SMC interface on ARM, or you have a complex clock system. In between, we should not try to implement anything, I think, because it is very complex and the clocks are messy because you have dependencies, etc. And I think that the main solution for that is definitely you have a standard PV clock driver, which will provide you a clock framework, which is standardized. And you put a PV, a specific guest, which will manage all the clocks of your system. This guest will be critical because it will have access to a lot of stuff. But other than that, if you look at all board vendors, how their clocks are implemented, it's simply impossible to put this framework into Xen, and it would not make sense. But
so that would basically mean that the enumeration needs to be done in .0 or in a simple domain. So we rely on Linux to do it.
Not necessarily Linux.
Did it right. Unless somebody managed to have a system that is ECAM compliant and doesn't require quirks to start, which probably are not that many today, but at least that way.
I would say there is none today on ARM. Juno, maybe and one SDP, but even Xilinx, if I remember, that was not fully ECAM compliant. You need some initialization at the beginning. If you were willing,
remember honestly.
Yeah, if you were willing to move that code in U-boot, then yes, it would be good. I vaguely remember speaking with Edgar about that. But if we need to put the initialization of that in Xen, it's going to be a mess.
No.
It should not be in Xen.
No.
Yeah.
Definitely not. But having the requirement that, okay, that you have two solutions. You have a DOM0, deal with it. It will do the initialization. That makes 90% of the user of Xen having a working system. If you are working in DOM0 less, then you need to have U-boot, EDK2, grub, whatsoever, doing the proper clock initialization before. When you look at the what we think are the targets for DOM0 less system or the things related to safety island, for example, they cannot play too much with clocks. They will play with clocks in a very limited way because it has too many implications on real-time aspects, on power consumptions, etc. And they will probably not want to have something too smart, I would say. At least, for example, on the N1 SDP board, that's not the goal.
But that changes quite a lot your model, because you either allow, well, let's say DOM0 populates the bus inside of Xen, or you allow Xen to discover the bus by itself, depending on which model you choose.
Yeah. It's the question is, do we need all models or should we limit them?
For what is worth, on x86 Xen is the one that discovers the bus in general. We have a brute force scan of the bus, which goes from 0 to 255.
Well, discovering them is one thing. The problem is the enumeration. If we discover them and we don't enumerate them, then we did not really solve the problem, because we would still rely on Linux to do that.
By enumeration, I guess you mean bar placement and sizing, and this is usually done by the firmware also. So when you put on x86, you have that set.
On x86, that's very much up to the system firmware to do. It is not a responsibility of the operating system. Linux is capable, and indeed most most operating systems can go and re-enumerate the bars, and that will happen in the case that they've discovered that firmware has done it wrong. So if the bar placements overlap or don't match up with bridge windows. But again, that is very much a quirks aspect for broken firmware and not the default.
As far as I remember, it's Linux that's doing it on ARM.
Yes.
Sadly, most of the time, yes. There are some, when you have EDK2 as a firmware, it is relying, for example, on newer boards, relying more and more on the PCI bus on ARM. Most of the time, the firmware actually needs to do something because it needs to use one of the PCI devices. For example, EDK2 might need the Ethernet device, which is on the PCI bus, so is able to enumerate. But it's not a 100% case, definitely not.
There's one middle option, which is that you let, you add the traps to the bar registers, and then you let DOM0 enumerate them, and you replicate what DOM0 does into the physical bar and into the P2M of the DOM0 second stage translation.
Which is the idea, but then you have, so that means you emulate.
You trap accesses to the bar registers, but that's mostly it. On the PCI header, that's what we do on x86 already, so you have the code there.
Yes, that we do, but then we have to have the enumeration before. Or you want to do that
for that to work, you need to know where config space is first, and it sounds like this is actually fairly easy on x86 because it's in one of exactly two standard locations, either legacy IO config space or MM config space on newer stuff. And for ARM, it's a total mess of having to turn your timers on before you can even read config space on certain bridges.
Oh yeah, but my thing would be to forget about those for a moment, and either people put this kind of initialization in the firmware in U-boot, or you don't support those.
Fundamentally, it's suffering from a fact that there is no standardization in something that really ought to be a firmware aspect to turn on.
I think you can do a prototype to impose to do it in U-boot, but I think in practice you're going to have some vendors saying, I want to do it in Xen, or I want Linux to do that. So unless ARM is doing what they did with the server-side SBSA.
I was going to say, exactly on this topic, Bertrand, maybe we should dig into eBBR. Because that's the embedded standard. I wonder if they added something on PCI. I don't recall it, but if it's not, that's something we could ask to add to the next version of eBBR.
Okay,
go on, Bertrand.
Okay, I think it's a valid point. We should try to standardize things, but honestly, if we wait for the standard to be compliant to what we do, in 10 years, we might have something at the best. And
right. Well, that's not. Well, I'm not really optimistic usually on these things, but keep in mind this is not a hardware standard; it's a firmware and software like boot standard. So it only takes we can change the software, right? We don't have to wait for hardware cycles. So it might not be as bad as you think.
You have to be careful with software standards. And like the SBSA is one example, is people have been claiming to be compliant with it, but they are not. So even if hardware has been released after the standard, it's really easy to mess up. Yeah. And that's not ARM that's going to tell them, look, you did something wrong. You need to fix your software. They will tell you, and you have to fix it, and you have to deal with it. That's the source of software development, sadly.
So, as an example, see what happens in the x86 world when Microsoft starts caring about something. It becomes a requirement of the Windows logo testing or whatever, and suddenly everyone will make their hardware pass Microsoft's tests. Which is not to say that they're standard compliant. The point is that there are some hardware bodies doing testing that are not just Microsoft, and some vendors are starting to conform around that. If you look at things like the Linux firmware update stuff, okay, slightly different topic, but now suddenly a whole load of vendors are standardizing around an EFI way of doing it that comes with even more checks and confirmations of whether something is right or not before it gets out into the world. So there are ways to try and drive towards standards, but it requires active work at this point for gain in 2, 3, 5 years' time.
There is for sure ways, I agree, but I'm not quite sure that we have the same power over the whole ARM users than Microsoft has. ARM can maybe try to say that this is a standard by saying we will implement the open source code with respect to the standard, and it will work on our reference platform. But you should not push completely aside the fact that if we do that and we support only our boards, that means nobody will use it at all. So it's
that's why I said DBBR, because that was signed off by a number of companies, right? It's not just ARM.
I'm open to help and try to definitely we should also fight this front, but I would not want to block everything, saying that we will wait for this to be a standard somehow.
So in reality, with my x86,
it's 6:30, so the time is up. So you can stay here, but just so you know.
Yeah. I think on this subject we could speak for hours anyway. So okay, let's try to kind of sum up, or at least take a status. This will be an ongoing discussion. So we for now, so there is a problem with enumeration. Definitely, we identified it. Right now, our code is relying on Linux doing it, which works. And we know that we need to find a solution so that we have a DOM zero-less system working. Currently, definitely I like the DTB solution. Why is that? It's because the amount of code that we would add to Xen is fairly limited. That you read some values from the DTB and you just apply them. It could be even more straightforward by saying what value to apply where, but I don't want to go this fast. And the enumeration right now, I'm not quite sure how to deal with it. So detecting in Xen should be possible, but I take from Julian that definitely it's not that straightforward. And definitely that means we need to do some more research on more hardware. So do you agree, or is there a quorum agreement on this, or do you think this is the wrong path?
I mean, there's already code on x86 that would do part of this, so it may be fairly trivial to just go with something like what I said before, that you discover the devices and then you just you add traps and then you let them zero position the bars. If the PCI is properly configured and the clocks are set up and so on, this should mostly work because the code is already there. So it should be quite painless to get this working. Whether you need something else, that of course depends on the hardware. But for example, sizing and alignment and so on inside of Xen, it's going to be impossible, at least when using ACPI, for example, because Xen doesn't have the full memory map. So you won't be able to do any of these bar placement and so on inside of Xen when there's ACPI in the middle.
I'm just in this, if we do that, what is the one versus using what we are using right now and just using the Linux hypercall so that Xen is informed?
You have to issue an hypercall. You have to issue an hypercall. So you have to modify the guest in order to issue the hypercall.
It's already there. We did not modify anything in Linux.
What if you're running Zephyr as DOM zero, for instance?
Yeah.
Right?
What if you're not running?
Definitely not the use case. Okay.
But yeah, I mean, the point for me was to try to modify DOM0 as little as possible in order to run as a DOM0 on PVH.
So in fact, there are three cases, right? There is Linux as DOM0, something else as DOM0 is no DOM0.
Yeah.
Yes, yes, you're right.
The thing is, DOM0 needs to be aware of Xen. It's not possible to do without it.
Unless you do the VPCI way, where you intercept every call, and you just wait for Linux to have done his enumeration to actually get the devices. But that's realistic. Okay. Yeah. Okay. So
also on the DOM0 needing to be Xen aware, I will point you to yesterday's presentations from the Bearflank people who have got Windows with no extra drivers working fine as their DOM0. So it doesn't require it doesn't fully require DOM0 to be Xen aware, and in particular, I think the close development between Xen and Linux in the past has led to some poor design decisions, which would be better if we could undo.
Okay, yeah. I agree it would be better not to have any dependencies on DOM0. But the only way I see... okay. Okay, if you take the Zephyr case as DOM0, one way or another, even though we would discover the devices, you would need to do the PCI enumeration in Zephyr. So, yeah, okay, that's possible to do. Okay, so definitely we will check the x86 device discovery code to see how complex it will be to port it or to use it on ARM.
At the moment, it's very, very minimal, so I don't expect it will be too complicated.
Okay. And what we can win on it. Okay. Because from this, we could win the detection only part in Xen. That means if the firmware did the enumeration and the address assignment before, then we would have everything for this use case, right?
And that would probably be a fairly good way of attempting to drive standards. I mean, if you've got something that works out of the box on 3/4 of the hardware and the other vendors want something that works easily, well, they either comply to the standard or they go and upstream code into Linux and Xen and whatever else they're wanting. So having something that mostly works is quite good at pushing other people with more problematic
Okay, so from this point of view, we could win the DOM0 less working with that because we could discover the devices without having to somehow declare the devices inside the DTB. So, okay, this is definitely a good solution. U-boot or EDK2 is enumerating the bus and assigning the addresses, and we use the x86
you don't
discovery
need
code
to assign the addresses. As long as you trap accesses to the bar registers, you could let whatever runs, whatever DOM0 or DOM0 less or whatever assign the bars.
That would mean, no, not really, because if we have 4 guests and you have 4 devices and you assign each one to a different guest, they will all try to assign exactly the same address to the bar. Well, in a case where there would be all the same size, etc. We can't rely on the domains to do the enumeration. Not the
in my case, it was a single domain, not multiple ones at the same time.
Yeah, but the point of Xen is to have several domains, otherwise we would not need that.
You can limit the bridge window, so each one get a different bridge window assigned. You can split the bridge window or something like that, but that's, well, risky, I think.
At which point you're just doing the enumeration in Xen for the bank?
Yeah. So I would say this middle use case we should prevent and say either it's enumerated and we use it, or not enumerated. Either the bar addresses are assigned and we use them, or someone is doing it, but Xen will not. At least this way, there is no in-between tricky state where we try to do something that might not work, 99% of the time at the end from previous experiences.
The thing is that the enumeration must be done by a single entity, or else you would get it wrong. I mean, you cannot assign 4 devices to 4 different guests and expect them to place the bars at the right position, probably.
Exactly. So if you have node on 0, then it must be done before, or by Xen, but we don't want this to be done by Xen, I would say. Yes?
So I think just a quick summary is we've been trying to get PCI passthrough on ARM for the past 5 years now, maybe more. I think I started when I was at Citrix, so that was probably 6, if not more, probably 7 years. It's a mess because of all the things. I think it would be important to get one platform working with PCI passthrough, or at least one platform implemented with keeping in mind what can happen on the sides. That should help anyone else to try to get at their code if they want, and then getting more users, getting more developers, etc. So the idea of having Juno and maybe N1 SDP support for now would be a good start.
Yep, I agree, definitely. My goal is definitely to try to push something which works on N1 SDP and Juno. I want to reach that goal. Well, I will try to reach that goal, or we will try, actually. I'm not alone doing that, or I'm not the main person doing that. This is Raoul is doing the implementation right now. But I agree, it's if we try to include too much features, we will never reach a status that we agree on, or that can be upstream. Okay. We will try to push a review for to get some comments on the mailing list this summer. It will not be fully usable, but it will be useful so that we can start discussing on the design, at least.
I don't think it matters to be fully usable. It's better to include the community as soon as possible, because you don't want to. The last thing you want to do is spending 6 months on getting something that works, and then the community saying it won't work, or if they won't accept for the design for whatever reason. So including something that doesn't fully work is still fine for us, I think.
Yeah. I will need to rebase on current master status and clean up our test comment and if 0 now and then, so that we can. But we will do that in the next week. Yes. Okay. So thanks everyone. That was very useful, I think. And yeah, if you have other ideas or things that we had no time to discuss, don't hesitate to drop me a mail or try to catch me on IRC when I am on it, which is not as often as I would hope. Yeah. Okay.
All right. Thank you.
Thank you, everyone.
Thank you.
For everyone else listening right at the moment, the virtual pub has opened again. We are in the first of the meeting rooms if you go to the virtual event summary, for anyone interested in drinks and a chat.
Sorry, I will not join tonight. See you.
Okay. Bye-bye.
Bye.
For everyone else, see you tomorrow.